since we've started to work with the periodic table a little bit, we're going to now take a look at the history of the development of the periodic table. And so in the 1700s, only a few elements had been identified, such as like copper and lead. They had been around since ancient times. This early organization of elements grouped the elements by similar chemical properties. They were based on how they reacted with other elements. So Johann Dobmeier, a German in 1829, used a triad system, and again this was based on chemical and physical properties. And he observed that the atomic mass of 3 elements would form a pattern. This is where we get the triad system because it used 3 elements. The main limitation here was that not all of the known elements could be organized in this triad system. So, like any good science, when there's limitations, other scientists kind of take the lead to make the current system better. And this is what John Newlands did, and he arranged the elements in increasing order of atomic mass. And he noticed that every 8th element had similar properties. This brought about the law of octaves, oct meaning 8. And again, this system had some limitations. In this system, the limitations were that some elements were just straight up missing. They hadn't been discovered yet. So this law did not hold true for elements heavier than calcium either. So again, scientists kept advancing, and so in 1869, Mendeleev, a Russian, organized the periodic table by increasing atomic mass again. And what he noticed was that some chemical behaviors repeated in regular intervals, and we call this periodic. Anything that repeats in regular intervals is called periodic. So like the moon phases are periodic, the days of the week would be periodic. And that's why magazines are called periodicals, because they come out in regular patterns. So the atomic masses increased from the top to bottom of the columns, and the elements in the same row exhibited similar chemical properties. And so Mendeleev's periodic table is pictured over here for you. And what you might notice is that he left blanks or put in elements with question marks because he predicted that these elements existed, however, they were undiscovered at that current time. So in 1913, Henry Moseley, an Englishman, examined X-ray spectra of all the elements, or of many elements, and his results led him to determine the definition of the atomic number. So remember, the atomic number is equal to the number of protons in an element. And so he then arranged the periodic table according to this atomic number instead of atomic mass. And so this gave us the periodic law, and it says when elements are arranged in order of increasing atomic number, there is a periodic repetition of their chemical and physical properties. And this resulted in the periodic table that we know today. So in the periodic table today, each new horizontal row corresponds to the start of a new principal energy level. And this is something that we looked at last chapter. So the periodic table is a way of arranging the elements in order of their atomic numbers so that elements with similar properties appear in the same vertical column or group. So an important thing here is that the current periodic table is arranged by atomic number. Every attempt prior to Henry Moseley's was arranged by atomic mass. In each square of the periodic table, we see the chemical symbol, the name, the atomic number, and the average atomic mass for each element. So then we have periods and groups. Periods are the horizontal rows on the periodic table, and there are 18 total. They begin on the left side. Each new period starts a new principal energy level. Remember, that would be N equals 1, 2, 3, all the way up to 7. Periods 6 and 7 have 32 elements because the two bottom rows are separated out. So remember, that would be the F sublevel is separated out and placed below so that it fits on one page. Groups then are our vertical columns. Oops, sorry. Here we have 7 periods, only 7 horizontal rows, and we have 18 groups. Had those backwards. The traditional naming system for those groups used A and B. However, a second system was developed which led to some confusion. And now the International Union of Pure and Applied Chemistry, IUPAC, numbers them simply 1 through 18. So on some periodic tables, you might see them labeled with A's and B's. These are old periodic tables. And however, the newer ones will use just the numbers 1 through 18. So here's a look at our current periodic table. And what you might see is that we have the A's, the 2 A's up in there. And then down here we have the B's. So that would be the old school system. And above that you will see that there are 1, 2's, and 3's in the new fashion of arranging the periodic table. So other organizational systems of the periodic table is that we have it divided into metals, nonmetals, and metalloids. Metals are any elements that are good conductors of heat and electricity. They're malleable, ductile, they have luster, and they're solid at room temperatures. So malleable means that they can be hammered into sheets. And that would be like aluminum, as in like aluminum foil can be hammered into sheets. Ductile means they can be stretched into wires. Nonmetals are any elements that are not a good conductor of heat and electricity. These exist in all 3 states of matter at room temperature, however most are gases. They can be brittle, they're not lustrous, and they have low melting points. Backing up again, metals are found on the left-hand side of the periodic table. Nonmetals are found on the right-hand side. In this particular example, these ones are color-coded blue, and our nonmetals are green. And then we have a period of transition called metalloids. These would be the orange on the periodic table. And they're on what we call a stair-step line. And these separate the metals and the nonmetals. These are elements with properties that are intermediate between those of metals and nonmetals. So aluminum is considered a metal because it has more characteristics of a metal than a nonmetal, whereas all of these in orange will exhibit some properties of metals and some of nonmetals. So that's just a brief look at how our scientists developed the current periodic table.